Welcome to the Deep Dive. We're here to break down the big ideas shaping our world. Today, we're diving into something that, honestly, could really shake up the AI landscape. It promises leaner, faster AI, maybe even the next big evolution. We're talking about Google's new AI architecture, Mixture of Recursions, MoR for short. So, okay, let's set the scene a bit. You probably remember back in 2017, Google Brain introduced transformers.
Oh, yeah. Absolutely game-changing.
Right. I mean, they power basically everything now. ChatGPT, Gemini, Claude. Even OpenAI's Sora video model relies on that core idea.
Hmm.
But here's the twist. What if those same minds at Google have just cooked up the thing that replaces Transformer?
That's the exciting part. It really looks like they might have. This new architecture, Mixture of Recursions, or MoR, comes from Google Deepmind and Google Research. Yeah. And it's not just a small tweak. They're positioning it as potentially the successor.
Wow.
Yeah, and the claims are pretty bold. We're talking things like twice the inference speed. Yep. And a memory footprint that's cut in half. Plus, needing only half the compute power for training.
Okay, that sounds almost too good.
It does, doesn't it? But wait, there's more. They're saying it performs better than models twice its size.
So smaller, faster, less compute, and better results.
Exactly. It's not magic, obviously, but some really brilliant mathematical design choices seem to be behind it. It really challenges how we think about scaling AI.
Okay, those numbers are staggering. So how does it actually pull this off? Is there some hidden catch, or is it just smarter?
It's definitely smarter. The core idea is really clever, actually. Think about traditional transformers. Every single bit of information, every word or token, goes through the entire processing stack, like maybe 100+ layers.
Right, the same path for everything.
Exactly. MoR is different. It basically asks, does this specific token really need all that heavy lifting?
Oh, okay.
So simple tokens, things the model gets quickly, they can sort of exit early.
Like taking an express lane.
Precisely. But the more complex tokens, the ones needing more thought, they can loop back for another pass, get more processing.
So it adapts the processing effort based on the token's complexity.
You got it. It's like giving the model a brain that knows when it's done thinking about something simple or when it needs to, chew on something a bit longer.
That makes intuitive sense. Almost like a dynamic router for information, a sort of traffic cop for tokens.
That's a great analogy. Yeah, a traffic cop deciding the route in real time.
So less wasted computation, obviously. Less memory getting clogged up.
Exactly. And that leads directly to faster results. And you mentioned memory. That's key, too.
How so?
MoR only keeps the active tokens in memory, the ones currently being processed. Transformers tend to hold on to more, even stuff that's done. MoR is more efficient, constantly clearing out what's not needed.
Which explains the smaller memory footprint.
And the performance proof is pretty compelling. They've shown, for example, a relatively small 118 million parameter MoR model. It actually outperformed a much larger 315 million parameter transformer on few-shot learning tasks. That's, learning new things quickly from just a few examples.
Impressive. More capable with fewer parameters.
And there's more. A 1.7 billion parameter MoR model beat similar size models, but used only 1/3 the weights, ran twice as fast, and didn't lose quality.
1/3 the weights and twice the speed. That really makes you question the old bigger is always better approach.
It absolutely does. It shifts the focus towards efficiency and smarter processing.
Okay, this is where I think it gets really interesting. Beyond just being faster and smaller, you said it's like a brain that knows when to stop thinking. Does that imply something deeper about how it operates? Is it thinking differently?
I think that's fair to say. It's not just efficiency for efficiency's sake. MoR integrates planning adaptive computation right into the core loop.
So the model itself is deciding?
Yes. The model itself decides, dynamically, does this task need all 100 layers, or can I figure it out with fewer passes? It's more adaptive. Some might even say more human-like in its approach.
Human-like? How?
Well, in the sense that it's allocating cognitive resources based on perceived difficulty. It's not just brute forcing every single input through the same rigid process. There's an element of internal metacognition, you could say. The model is thinking about its own thinking process in a way.
That feels like a pretty fundamental shift. So let's pull back. What does this mean for the future? Is this curtains for transformers?
Well, probably not immediately. Transformers are deeply embedded. They work really well.
Right.
But this definitely feels like the start of a new chapter, maybe a new era. Remember how transformers eventually replaced RNNs?
Yeah, that was a big transition.
MoR could be that next major leap.
Yeah.
It changes how AI might think, reason, adapt. Of course, other players like Meta, OpenAI, xAI, they're all doing fascinating work too. But right now, it feels like MoR is the one making everyone really stop and take notice. It's almost like, eh, you know, Google Brain gave us attention is all you need in 2017, the foundation for transformers.
Hmm.
And now, maybe with MoR in, say, 2025, they're potentially writing the next chapter in the AI playbook all over again.
That's a really powerful way to frame it. Okay, final thought for everyone listening. If MRR brings this adaptive, maybe more intuitive thinking to AI models that know when to stop and think or when to go deeper, how would
Yeah.
that change things? What new possibilities does that unlock for you? We hope this deep dive gave you some food for thought on where AI might be heading. If you found this valuable, please do give it a like. Maybe share it with someone else who loves to learn about this stuff. And definitely subscribe to the channel so you can join us for our future explorations. Thanks for listening.